Hey guys, so last lesson we did solving system of equations graphically, and you could graph both functions and see where they intersect, and that would be your point of intersection, which would be your solution for both. Now we're going to learn how to do it algebraically. So when you do it algebraically, there are two different ways. The first way we're going to learn is called substitution. So we have two equations here, and yeah, we could graph both and it'd be very easy, and the cool thing is you can always still graph both and check your answer, which we'll probably do at the end, but we're going to learn how to use substitution. So when do we use this method called substitution? And if you look at these two equations, a dead giveaway that you're going to use substitution, or that substitution is the best method, is if you have one of the two equations are in either x equals or y equals form. And now here, this top one, y equals. It's in y equals 6x minus 11, so it's in y equals form. So what that means is this. If we try to solve one of these equations, you have two variables, it doesn't work. So our goal is to get rid of one of the variables. So I'm going to take what y equals. Y equals 6x minus 11, and I'm going to plug that in for y, because that's what y equals. So we're going to get negative 2x minus 3 times 6x minus 11 equals negative 7. Now, if you notice, we had two variables. Now we only have one, x and x. It's only x, so you can solve this. So let's do some math. Let's distribute. We get negative 2x minus 18x plus 33 equals negative 7. That's negative 20x if you combine these like terms. Plus 33 equals negative 7. Subtract 33. You get negative 20x equals negative 40 divided by negative 20. And we get x equals negative divided by a negative positive 2. So we're halfway done with the problem, a little more than halfway, but we've found one variable so far, x equals 2. Well, now if I know x equals 2, I can go back and find out what y equals. Now how would I do that? Well, take x equals 2 and plug it into either one. It doesn't matter, the top or the bottom. I always say pick the one that looks easier. So which one is it easier to plug x into and solve for y? Well, what about the one that's in y equals? So I'm going to take this and I'm going to do y equals 6x minus 11. And put y equals 6 times, well, x is 2, minus 11. So y equals 12 minus 11, y equals 1. So the point where these two lines will intersect is when x is 2 and y is 1. In other words, 2 comma 1. Okay, so what you're going to do is you're going to try 3 and 5 in the same way. Now, let's look at 7 or 9. Let's look at 7. Okay? Here we say, okay, we have a system of equations, two equations. However, neither is in y equals form. Well, you can easily make one of them into y equals or x equals form, and it doesn't really matter which one you do. Let's do this top one here. Let's take negative 4x plus y equals 6 and get that into y equals. Well, that's as easy as add 4x. So you get y equals 4x plus 6. And now it's almost as though this equation right here is the same, it's just turned into this. So now that I know y equals 4x plus 6, I could take 4x plus 6, plug it in for y. So we get negative 5x minus, don't forget that minus there, parentheses, 4x plus 6 equals 21. Negative 5x minus 4x minus 6 equals 21. Combine like terms. Negative 9x minus 6 equals 21. Add 6. Negative 9x equals 27. Divide by negative 9 and you get x equals negative 3. Now don't forget, next step, take what x equals and substitute it into either one. It doesn't really matter. Let's do negative 4 times negative 3 plus y equals 6. So that's 12 plus y equals 6. Y equals negative 6. So that means, what is the point of intersection? Negative 3, negative 6. And let's just quickly check that, and then we'll be done, and I'll let you guys go ahead and finish the rest of these. So we get negative 4x plus y equals 6, and negative 5x minus y equals 21. And remember, we're looking to see, is it at negative 3, negative 6? Sure is. We did it correct. Okay, so please finish the rest of these 3 problems.